Hello friends, today we want to look at global mathematics, and that is one of the topics that we find challenging as senior high school students. And so I want to take this time to explain it to my best for your understanding. So don't forget to like and subscribe to the channel, and you can ask for more videos. Comment in the comment section, that I will be able to release more videos onto you. Alright, so we take our first example, then we will look at some definitions also. But before that, before the days of ancient Greek thinkers, the earth was believed to be flat and disc-like. But today science has advanced and the earth is known to be spherical, and so therefore calculating distance on the earth's surface requires some knowledge on circles and their association with imaginary lines on the earth, which is what is leading to global mathematics. So we want to look at some properties of circle. Before we can deal with global mathematics, just like we said, some imaginary lines, we need to know the properties of a circle, since global mathematics is dealing with properties of circle. And so the round thing we have seen is the circumference of the circle, which is given as 2 pi r, and then we have the center O, we have the radius. Any line that is subtended from the center to any part of the circumference is called a radius. So we have two radius over here that is forming the triangle A, B, C. So we have another angle inside there, and that angle that is subtended by the 2 points A and B at the center of the circle. So when we are looking for an angle that is subtended by two different radii, we call it an angle of a segment or a sector. Alright, the line we've seen here is line AB, which is the shortest possible distance through AB. You realize that we can pass through A through the line like this to B, but the shortest possible way of passing is through A straight to B, which is this line over here. Alright, and you can also pass from A, go around the circumference until you come to B, but likewise the shortest possible is still from B to A, any of them. Now from A to B through the circumference is what we call a curve, which is a curve AB, and the shortest distance on the earth's surface between the points A and B. So if you are also passing here, it is shorter than you passing over there now until you come over here. Now at the end of this particular lesson in this video, we should be able to explain some terms associated with global mathematics, and we should be able to locate points on the earth's surface given their latitude and longitude, determine the angle subtended by any 2 points in the center of the circle on which they lie, and also determine the radius of great and small circles, calculate the shortest distance between any 2 points on the earth's surface. Now, what are latitude and what are longitude? So longitude actually are imaginary lines that are drawn from the north to the south pole, or the other way around. So that is what I mean. And just like the globe, these lines are the lines of longitude. So every line of longitude makes a great circle. So if you cut any longitude, you divide the globe or the entire earth into 2 equal parts. Now we call the 0-degree longitude as the Greenwich meridian, and that is what the time is being calculated on using. So we have the North Pole and the South Pole. So in our questions they can ask us where the particular plane is moving from and where it is going, and the angle in which it's moving, and we'll be able to calculate its distance to the Earth's surface. Now, if it is moving to the east, we said is due east. It is moving to the west, we said is due west. So your aeroplane, for instance, is it moving due east or is moving due north? In the question, it will be tell. Now we have this as 40 degree. Realize that it is in the western side. So 15, 30, 45, 16, all these they are in the 30 side. When you are going to the eastern side, this is an example. 15 degree is also in the eastern direction. Now latitude are now also some imaginary lines drawn from east to west. So you realize that for the longitude they are drawn from north to south, but the latitude are drawn from east to west, just like an example below. So these are latitudes. Now every latitude cannot make a great circle, so it means that we have only one great circle, which is the latitude 0 degree. We have only one great latitude. So due north, example is 70 degree north, and due south, example 70 degrees south. Okay. So if the question is saying that it is moving due 70 degree due north, so I'll draw like this on latitude. So this is how we draw the line. But if it is longitude, it means your line is going to be this. But remember, this is not north. So when you are dealing with north and south, it means that the thing will be related to latitude. When you are dealing with east and west, possibly it is more related to what? Longitude. Just keep that. And so great circles. So circles that divide the earth into two equal parts. Like I said, longitudes are all great circles, but latitude have only one great circle, which is the equator. That is latitude 0 degree. So small circles that divide the earth into two unequal parts are the small circles. Latitude are small circles, except the equator. Now let's look at what great circle and small circles are. So this is an example of a great circle. It is dividing the equator into two equal parts, or it is dividing the earth into two equal parts, as we have seen over here. So this is a great circle, and then we can also have a small circle. See that it cannot divide the earth or the globe or the sphere into two equal parts, but just a small space over here. So this is what we call a small circle. Now, the center of a great circle is also the center of the earth, and the radius of a great circle is also the radius of the earth. You get that? So it is mostly giving us 6,400 kilometers, and we write that one as a big R. So anyway, you are seeing us using big R, then it is referring to the radius of the entire earth. Now, all longitudes are great circle, like I said earlier, and then latitude 0 degree is also a great circle. Apart from that, all the latitudes are small circles. So calculating the distance between 2 points A and B on the earth surface for great circles. So we are trying to see how we can calculate some questions on great circles. So these are the steps we have to follow. First, you need to draw a circle to represent the earth. Remember, the earth is more of like a spherical something, so we need to draw a circle to represent the entire earth. Then next, we draw the latitude and longitude values given in the question. So in the question, is it saying that latitude is 40 degree or longitude 40 degree? We draw that on the circle before we move on. So these are the steps. The third step is that you have to locate the point at the intersection of the latitude and longitude. So in the question, maybe we have been given longitude and latitude. You draw those lines, imaginary lines, on the circle you have drawn. And when they intersect, that is where you locate the point and you label it. Is it point A or point B, where the thing is moving from. Now draw a circle connecting the 2 points and determine the angle that is there. So calculate the distance using the formula AB equal to theta over 360 times 2 pi r, where the r, like I said earlier on, is the radius of the Earth, which is 6,400 kilometers, and the angle formed by the 2 points that you have drawn is the theta. Now we take an example. Let's calculate the shortest distance between the 2 points. A 15 degree north, B 15 degree east, and then it's still on B. So B is 20 degrees south and then 15 degree east. We first have to draw the circle. Get your north, south, east, west. That's the cardinal point. Now draw your degrees on it. So 20 degrees south. 20 degrees south. So you see the south is over here. 20 degrees south, which is the latitude. Then the next one is 50 degree north. 50 degree north will also be a latitude. So 50 degree north will also be a latitude. Then this one is 15 degree east. 15 degree east is just on the eastern side. Then the 50 degree north, like I said earlier. Now locate where these 2 points meet. You see that the eastern point met with the 50 degree north is here. So we are labeling the point A, which is this. So we have point A, 50 degree north, and then 15 degree east. This is where they met. We also have 20 degrees south and then 15 degree east. This is where they met for B. And then you locate the angle from there between this point to the center and to the B. We are looking for this angle. Now we can redraw it by looking at it this way. This is how you can picture it using the group. Okay, so from this distance to this distance, A to B, on 50 degree north and then 20 degrees south, the angle formed here is 50 and then 20, 50 and 20. So we get to get a sum, and the sum is going to be 70, which is the entire of this piece. So theta is equal to 50 plus 20, which is 70 degrees. So we can draw this small arc out. If we cut this one out, more like this whole area, we get a circle over it. So we get a circle, it means AB is 70 degrees in that angle formed. And we can just use the formula to calculate for it. So using this formula, AB is equal to theta over 360 times 2 pi r, where pi r is the circumference of the entire Earth. So we know the r to be 6,400 kilometers and the angle we have found to be 70 degrees. Now substitute everything inside the formula and you are getting 7,820 kilometers as the shortest possible distance from A to B. Now the next example, example 2. Two towns M and N are located on a common latitude 35 degrees west. So they are on a common latitude. So this one I'm going to draw one latitude. Okay. While N is on latitude 5 degrees north, M is on latitude 50 degrees north. They are all on the same sector. They are all in the northern sector. So given the radius of the Earth as 6,400 kilometers, calculate the shortest distance along the Earth's surface from M to N. Alright, we get a solution. The first step, remember, we draw the circle. Get your 30 degree west. So 35 degree west. That's what you have drawn. 35 degree west. It is the western side. So we draw it 35 degree west. Remember, if it's north or south, north should be this side, north should be on the top and south should be down. But when we are talking about east, it should be this way and west should be this. So our point is 35 degrees west, so it will be on this side. And now the N is on 5 degrees north, so I'll draw 5 degrees north on top. 5 degrees north. And this on the same plane we have 45 degrees north. So they are all moving on the same plane. So look at where it points and this one also moves. And then we label them point M and then point N. Now we continue with it. Join these 2 points to the center and let's pick the angle formed over there. So you can also pick it out as the edge. Now when you get it, we have to sum the angles that are formed if they were on different directions. But here's the case, they are all on north. So if they are both on north, you subtract because they are all moving on the same lane. So we subtract it. And then when you take 45 minus 5, you get 40. So the angle formed there is 40. And then use the formula once again to calculate for the shortest possible distance. And so theta over 360 times 2 pi r. Then we know the angle is 40 degrees because when we're looking at it, the angles that is from there are on the same latitude. So since they are on the same latitude, we subtract. But if they are on different latitude, we add. So let's say latitude 35 degrees south or latitude 15 degrees south and latitude 15 degrees north, then we add. But if they are all on the same latitude, south, we subtract. If they are all on the same latitude, north, we subtract. So take note of that. That's why we have to subtract and to get that 40 degrees. And now just substitute the formula. 40 over 360 times 2 pi, and pi is giving us 3.142 times the radius of the edge. And there is a shortest possible distance along the line of longitude between the two towns, M and N, is 4,469 kilometers. Now, let's look at the properties of a small circle. Just as we have looked at the properties of a great circle, what are the properties of a small circle? So don't forget to like and subscribe to the channel. We are just looking at the properties of a small circle. And this is an overview. There are other videos which you can watch. And feel free to pause the video. If you have seen any question, solve it and then put it on the comment below what I need to improve on. Now let's continue. So the center of a small circle is not the center of the earth, like we said earlier on. Any 2 points located on a common latitude other than latitude 0 degree, which is the equator, from a small circle. The radius of a small circle is small r, which is not equal to the big R. So we have to find that one using a particular formula. So calculating the distance between 2 points A and B on the edge surface for a small circle. That's what we're going to do. For example, so the steps are: draw a circle to represent the edge, draw the latitude and longitude values given in the question, locate the point at the intersection of the latitude and the longitude, and now draw a circle connecting the 2 points and determine the angle. Calculate the radius r, the small r, of the small circle using the formula r equal to the big R cos beta. So the beta here is the angle we have gotten in this step. That's the beta. Now calculate the distance using the formula theta over 360 times 2 pi r, and the r here is the small r, the radius of the small circle. So example 1. Calculate the shortest distance along the line of latitude of the earth's surface between the two towns Q 45 degrees north and 45 degrees west, and P P 45 degree north and 45 degree east. So they are on different longitude, but on the same latitude. So given that the radius of the Earth is 6,400 kilometers, that is the big R. Draw your circle. So draw the 45 degrees west on Q, and then 45 degree east on P. Now draw the common latitude, 45 degree north. So where they intersect, so from 45 degree west and 45 degree north and Q, this is where they meet, and then this one, that's where they meet. You label it P and then Q. Then we get the angle we are looking for. So realize that this one is not forming at the centers, therefore we cannot use the big radius. So we have a small circle forming here, so we have to use that small circle. Let's cut it out, then you see what I mean. This is what I mean. So that this is a small circle, it's not in the center. You have to get a small circle out here. We can illustrate as this. So we add the two angles given to us, and we get 90. So the angle formed at the top here is 90 degrees. Alright, let's continue. Now that I know that angle, we use the formula to find the small r. So the big R is already given to us, so we'll find the small r. When we find the small r, beta is 45, that is the common latitude. The common latitude is only the beta, and then the r cost beta. So we set it inside and we are going to go. So r is equal to 6,400 kilometers cos 45, which is 4,525 kilometers. That's the radius of the small circle. So we substitute inside the formula and you are good to go. So your answer for the shortest possible distance along the line of latitude between the two towns Q and P is 7,109 kilometers. Let's now look at one or two application questions. It is used to determine the shortest distance between 2 points on the Earth's surface, and it is also used to determine the time difference between 2 points on the Earth's surface. An aeroplane flies from point X 20 degrees east and 14 degrees north to Y, and Y is 20 degrees east and 28 degrees south. So they are on the same longitude but on different latitude. Then it flies from Y to Z. After it has reached Y, it flew to Z, which is also on 65 degrees east and 28 degrees south. So when it gets to Y, they are now on the same longitude, so latitude, but on a different longitude. Okay, so the distance covered by the aeroplane, we should find it, and then the time taken to cover this distance if it flies at a speed of 500 kilometers per hour, and we take the pi to 3.14. The radius of Earth is 6,400 kilometers. We can use this diagram as an example. So it flew from X 14 degrees east, then 28 degrees east. They also have it moved from X to Y, and from Y it flew to Z. Getting it? So they are on the same line. So when I get it out, it's 14 degrees, 28 degrees long on the same longitude. And it's certain from Y to Z on different longitude and latitude. So now let's get the arc on the circle is XY subtended on the angle, which because they are on the same latitude, we subtract, and that's how we subtract 65 minus 20, and I'll get 45. Now the distance along latitude 28 degrees south is also given as the angle found here over 360 times 2 pi r times big R cos beta, and here the small r, so you can calculate before you substitute it, and your answer is this. So the total distance covered is now the answer for the first one plus the second one, then you are going to get 9,130.80 kilometers. 2. So that we find the time. So the speed we know is given to the question, that's 500 kilometers per hour. The distance covered is now 9,130.804 kilometers. So we know speed is equal to distance covered over time taken, and then we are looking for time, so we just need time to subtract, then we find the time taken to be 18.26 hours. Thank you for. Don't forget to like and subscribe to my channel. Watch the point, make your comment below, then I'll be able to release more videos for you. Thank you. Have a blessed day.